to see them anymore. You'll not be able to retrieve them. So you need to think about this. Also, how to put your logs in a place that you can retrieve them later. And for example, if you're using log4j, log4net, a solution like this, it has S3 appender, so it can upload at an interval on S3, and you can also do your own scripting, like some PowerShell or some bash scripts. Take your log files and upload it every 1 minute. And I know that log4net also has like a lot of appender for SQL things, and for NoSQL you can go in the MongoDB, which will not go down. So you need to solve also this problem. On the monitoring part, the solution provided by AWS is called Cluj. So you have all the standard metrics for the CPU, the disks, the network, how many requests you get, how going out, and you can also build your own custom metrics. And here you need to do all this scripting stuff like PowerShell, Bash, or some other things, JavaScript if you want to do. And then you will take all these metrics that are important to you, and you will put them on the cloud. And once you put them there, you can define alarms for them. If they go above a threshold, okay, so let's say if we have here, I would reach on 5,000 requests, and say I would want to fire one more machine. So you will put an alarm, and on the alarm, you can actually, let's say on the first instance, would be to fire some email. But if you are able to auto-scale, you want just to get an email that another instance was launched. And the good part is you can put the threshold also on a lower value. So let's say here if I get below 50 requests for 5 minutes, I would stop one of the machines and only leave one or two. Never number I needed. Okay. So the problem with auto-scaling group on AWS is that it's based only on one metric. This is one of the main problems. You cannot scale, let's say, based on how many items you have on 2 queues. You can only scale on only one. And the only solution would be to have, let's say, a custom metric made of more metrics. This tends to be a little problematic because this new metric you need to push it from your application. So you need some, I don't know, another script running every 5 minutes, counting, and that script is running on a machine, so you need a machine to. So it would be great if we'll have some auto scaling on more metrics, some metrics, or even deduct some metrics, something like this. And on the auto scaling part, you need to be careful because you'll need to define all these images for auto scaling. Whenever you deploy a new application, you don't want at the start to check, okay, is there a newer version or something like this. You need to every time when deployment create a new image. So throw away the old image, create the new image. So there are tools to do it. It's also easy to do it only with what AWS is offering you. So it's not really complicated, but you need to take this into consideration. Just updating one library there, you need to throw away the image and create a new one. Okay, so this is a bit of auto scale. Oh, you can check.
I'm curious if there is any particular reason for why you have chosen AWS.
Yeah, because
why
it
not
was.
Brazil, for example?
Why not?
Brazil.
Because it was infrastructure at the moment that we gathered all the feedback. So it was like in 2011. If you searched on Google, all the searches out that you found on AWS, okay, you can do a remote desktop SSH on that machine. You can install whatever you need. On Azure, it was like you just take the application, right click and deploy. And it's not really what you need, because when you are at the beginning, you don't want to think about one application, one machine. You want to use one machine for more things, like to have 10 applications. So it wasn't clear how to do it. It was, at that moment, it was platform. Azure was platform. This is the simple rule.
Then the question is, what would you choose today?
Yeah, this is a good question. I can't answer it just. But
Okay.
Yes,
It
it will need
depends.
reconsideration.
Any more questions for Liviu?
You've mentioned that you are using Redis for storing the session critical information. As far as I know, Redis by default does not make any kind of storage, so you keep the data in memory.
Right.
Are you also picking it up with some storage?
On AWS, we have you can deploy it as master slave, and it will do automatically the reverse. If they will check the health of the instance, and they will switch automatically. You have the master down the slave, and you don't need to do it. It's just handled behind the. And actually, this session provider for Redis, it comes from Azure. It was developed in mind for Azure. Like 1 year ago, they threw away the caching solution, which was from Microsoft, and they also integrated Redis in Azure. So that's why they developed this session provider. It wasn't for AWS, but it works. And it's like it works also locally. You can develop locally, and then you go live on AWS, and there's only change the IPs.
Yeah, so Redis was selected by Microsoft as their caching solution in Azure, and is sold in two variants. One is named Microsoft Azure Cache Service, but it's based on Redis, and you can also choose for the standard Redis deployment. More questions? Otherwise, I invite you to have a nice lunch, and we'll restart at 2:30 p.m.
With a client that has PCI compliance, you'll probably need a reverse proxy, something like this, to put in front of your load balancer. So you're going back to like the classic solution, solution of using some Nginx or HA proxy or something like this, for which you can control the IP yourself, and then redirect to your load balancer. Okay, and then you're getting to the session issue, which is the one which is the hardware to solve. Now, on the scaling thing that we initially talked, when you do it, it's only about adding more machine on the classic solution. And the solution here was to use the sticky session. The sticky session would actually put a cookie on the client and would remember exactly to what server to go. And this way you could keep your session in process, and you would arrive on the same server every time. And this was working, but you cannot auto-scale using this. You actually cannot stop that machine anymore, because all the clients that are redirected there, they will not have the session anymore if that machine stops. So you actually want to have a solution where your client to be able to go to any of your machines under the load balancer. And how we did it in a .NET world is you have three possibilities. There are more, but these are the session clients that are supported by Microsoft. So you have the state server solution, where actually the session is kept in a Windows service on one of the machines or in a separate machine. Then you have the SQL Server solution, which is pretty old and reliable, and I know that many companies use it. Okay, and now there is, for about like 1 year, there is this Redis solution, which is probably by all this breed, probably the best one to use, and this is what we are using right now. process, and when you go to one of these three solutions, you'll start seeing some problems that you don't expect. Like, for example, a session will be able to time out. Because saving something in a SQL machine or in a NoSQL machine can time out if it's a big object. And for example, on the Redis, the default timeout is like 1 second. So if it's not able to save in 1 second, you'll get a timeout. And it happened to us, and fortunately we caught it in the development process. And immediately, we were also live, we caught it in the development process, and immediately we increased the timeout to 2 seconds in production. What happens if it will give timeout is that all your machine, so all the machine, it will be done. It will not be able to process any more requests because it's an unhandled exception and brings all your threads down. So it's really nasty to have something like this. It's good that we got it on the development. Now on the session, here because for us, for example, became more clear why you need to put the big items, for example, in a cache solution and not to keep it in the session. Because keeping the session in a Redis cluster, it's actually caching it. But the difference between using a caching layer and the session layer is that the session it's loaded and saved on every request. So this is a problem if you have big items that are loaded at the beginning of your request and saved at the end. So you want to save if you put in session your search results or something like this, which are pretty huge, you would want to cache them. And okay, you can use the same Redis cluster, but just cache them along when you need them on demand, not on the session. Here it's a picture of the Redis provider in the NuGet manager, which is the package manager for .NET. So it's now at version 1.6, I think. So it's pretty stable. And in the back, it's using the client from Stack Exchange, so which is an old client. So it's pretty stable. We had something like this. So our application was an MVC, is an MVC one. And if you look and you Google it, you'll find a lot of articles saying don't use a response redirect in an MVC application, .sp.mvc application. And I can show you one of the reasons why not to use it. These two lines of code are working fine when you have the session in process. And they will stop working as expected when you go to a Redis one, or in state or in SQL Server, no matter what. Because what actually happens behind response redirect, they're actually throwing an exception, like a thread abort exception, something like this. And everything, all the processing that should have been done by ASP.NET, so if they need to put a cookie on your response, it will not happen. If they need to save the session, it will not happen. So actually, the session, when you are in process, that line actually does also the saving. When you are out of process, one of other solution, out of process, that line doesn't do the saving part. It will be done at the end of your processing your request. So actually, it will happen that session item, it will not be saved in your session. If you want to get it later in another page, you'll have another reference. This was the story behind it. And of course, don't use response redirect in an MVC application, but if you still want to use it, there's this parameter at the end, so which you can put, and it will actually not throw the exception. So the pipeline that the ASP.NET will continue to process, and when everything was done, it will actually throw the P302 to the client, and it will do the redirect. So the solution is pretty simple, but it can take you maybe more than 1 day to find out if you be able to scale web applications. You should be able to auto-scale. You should be able to stop them and to start them whenever you need. I can tell you a few things about how you can better scale the workers' applications. If you have something that does the processing behind it, you should be able to start your application, to start processing right away when you start. Not to have a big load. Don't even think about, I don't know, getting the latest version, doing the upgrade when you start, because when you start the machine, you want to start processing. This is because you usually start the machine when you have the need to process, or you have this extra demand. So, and you usually start, let's say, with a 5-minute interval. So if you have like a 10 minutes warm up with checking if the application is the latest version, you will end up firing a lot of extra machines because you will not start the process. And one thing that we learn is your application needs to be able to stop processing, because you will stop those machines and the application will not expect this. So, for example, if you take one item from a queue and process it, that is okay. But if you want to, let's say, 10 items from the queue, and to have, I don't know, maybe because of performance, not to make all the HTTP requests, and if you want to take 10 items from a queue, you might stop it in the middle of processing. So 5 might not be able to process. And actually, if you're in a Windows environment, it's pretty simple because Windows services have their own start and on stop. So on stop, you can deal with this unprocessed data and put it back in a queue. You can also work on your queuing system or whatever to be able to put back itself all the data that you didn't delete or something like this. So there are solutions to this depending on what you're using. Okay, now that you are able to auto-scale, the auto-scaling is actually done on monitoring your application. So if you know what it's doing, you should be able to see that it's not able to process anything. So, and if you think about a better monitoring, you actually end up in thinking about the business metrics, because it's all these cloud platforms are coming with already installed monitoring solutions that can monitor your CPU, monitor your disk usage and all stuff like this. But you should be able to monitor your business metrics. If you see that your number of applications that you have where can process anything, and that would be a good counter on what you should be able to make the autoscale to go up or go down. Because you should also go down when there is nothing to process or when you are below some threshold. It's not only about going up. So if you think that when you start the application, let's say the design phase, when you need to think about what you are doing, it will be much easier to do this auto-scaling. And the one thing, if you want to monitor your logs, for example, we have some solution to monitor your logs. The problem is that if you write logs on your disk,
for example, other discovery services, like the one from Apache. So basically, it depends a lot of what you want to do. But I would say for a simple environment where you are not having, let's say, a larger scale application like Netflix does, a simple Eureka with backup on DNS would suffice, I would say.
Any more questions? Because I have one. How many of you have worked with any of these technologies? Okay, because the names are really Zen.
We have a question here.
Hi. For me, was not I couldn't completely understand the level of granularity for such a microservice. if you would get the task to, let's say, re-engineer an existing application with a simplified, let's say, three-layer architecture, presentation, middle layer, backend, and stuff like that, how would you port this to such a microservice architecture?
Okay, so basically the question is if you have an already existing application, only one, and you want to migrate to the cloud and using microservices, how you are going to extract microservices and how small or big should they be?
Exactly, and how you define the level of granularity. And just a bit to continue, do you get an approach where you follow like a top-down, something like that, or you just like bits and pieces everywhere? Because I guess that's something that you design only a microservice for a front-end component and maybe a microservice only for something in the business layer, or you do something all layer stack microservice.
Okay, so again, there is no recipe that works for everything, but the microservices should be, let's say, vertical as possible. That means that you, for example, if you are managing data, for example, of course, in the moment you have usually one database, big database, which is used, and you have going to extract a microservice, and that microservice is sending some data, then it will be property of the data, and that means that part of the SQL or whatever database you have will be extracted in its own database. That's one part. The other part regarding how big it will be, actually, when we are starting in our current project, when we started to extract, what we did actually, we took the business guys, the BAs, and we said, okay, let's see the functional areas of the applications. So, for example, we can identify an order management component that's within the application that will be extracted as microservice. You have, for example, a user management maybe that will be also extracted as microservice. And how big that will be, well, it depends a lot on the application. It can be very small. It can be like maybe 10 classes in Java, something that sit in no database, for example. It can be larger. It can be like maybe 200 classes and have maybe one big database behind. It's also possible. I would say that, in my opinion, what the best approach is to go on the business side. To go on the business side and see where are the, let's say, the borders, the business borders of your components. So your extract microservice should have one need only. So it should not cover multiple purposes. So if you extract the ordering, it does not have anything else but ordering, and that's all. And if you have something that's in between, let's say between order and maybe vendor management or something, maybe that will be better to be extracted on its own microservice that will somehow aggregate data from the ones.
Thanks. I got it.
Thank you, Ciprian. Next talk is about scaling .NET applications in in the Amazon cloud. That's an amazing talk. I mean, is it the place for .NET application in the Amazon cloud?
We weren't using any of the nice features of the AWS platform. And now, after a couple of years, we were able to bring an application to do the autoscale. So I'm going to try to define a little bit what does it mean to autoscale, because it's a very common word right now, but let's see if we understand it correctly. And the problem that we need to solve in order to autoscale would be to have a load balancer and to solve the session issues. And then we will see that actually autoscale would mean to have a good monitoring on your application, to be able to do it when it's the right time, when you have the demand. So it's about .NET applications, and I get this question quite a lot. How did we choose AWS in other competition? And to cut it to the answer, because it was infrastructure. And infrastructure, when we gather all the feedback, it's easy to start. And you can see this, that also Microsoft, which is now like number 2, switched to this approach. So they're also infrastructure. At the beginning they were platform. Okay. And do you know what scalability means? I mean, I have the definition here, but is it clear what means an application to scale? You can raise your hand. Okay. So actually you have two ways of scaling. We can scale vertically, and it means adding more resources to your machine. That machine should be able to process more requests. This would mean vertical scale. And you can scale horizontally simply by adding more machines. Now, all these cloud platforms are built for horizontal scale. They're not so good for vertical scale. It's hard to replace the machine and not have any downtime to change the IP and stuff like this. So they are built for horizontal scale. And scalability is actually about just scaling up. It's not about going down with the number of machines. So this is also something different. And actually, all my talk is about this picture here. If you want to take something, you can remember this, because autoscaling means going back and forth. So you can have 2 machines, or you can have, I don't know, going to 5 machines, and this is you will do it you want to do it automatically, and it's also horizontal. So this is the difference between classical scale, let's say. Okay, so is it clear? Now you want to solve 2 things when you have your web application. You want to be under load balancer, so your clients are pointing to only one place, okay? And you want to solve the session issue. On the load balancing, the solution that you can find on AWS is their elastic load balancer. And actually what it will do, it will fire some hidden machines. Here it's the white dots. It will fire, when you start the load balancer, it will fire these machines. And it's actually, even if you can put like only one of your machines under a load balancer, it will actually fire 2 hidden machines with 2 public IPs. And the solution would be that on the DNS, it will do a round robin. So whenever you do the lookup on the DNS, your client does the lookup, your IP.com, your URL.com, it will continually switch through those IPs. So it's a simple round robin. And has all the things that a load balancer has to have, like health check, and it has all the headers that you want to see if it came through HTTPS, what's the real client IP you want to take from the application, and it also has the cookie thing that redirects you to the same machine. I'll talk about it immediately. But what you don't have on the AWS load balancer is the IP control. And sometimes you need it. Like if you're working with some financial company, they have this PCI compliance when they need your IP to redirect to go there. They don't need only the URL, they need also the IP. And you cannot change it. And this load balancer actually does auto scaling in the back. So actually, it's if it starts to get more requests, it will replace these machines with stronger ones. And these machines, these new machines will have new IPs.
But not everything is better compared to the monolithic architectures. So there are also some problems and challenges that are going to rise once you're going to move to microservices. For example, you first had one monolithic application that was simple. You maybe was provisioning with Vagrant and Chef. The configuration was injected depending on the deployment environment you were using. Everything was nice and simple. But not anymore, because now your application actually is composed of maybe, let's say, 20 other micro applications which are microservices. And they all need to be instrumented and they all need to be configured. And of course, all of them will be scaled. Meaning that, for example, you will have one microservice running with maybe 20 instances. And all those instances have to be configured at the same time. And maybe you want to change that configuration at runtime and you don't want to do it with downtime. And how do you do that? Well, it's quite simple, actually. There are some tools in the market. For example, you can see I always, or most of the time I'm going to give examples from the Netflix OSS, the OpenStack solutions from Netflix. And that's why, because they are maybe not the first, but I would say among the first big companies that went to cloud. They built all their tools and infrastructure from scratch, and they prove that it's working actually. And we have a solution, for example, in this case from Netflix, which are offering Archeus, which is basically also standing at the base of the newly emerged Spring Cloud configuration server. As you probably know, Spring embraced the Netflix OSS in the past year, and they started to build, beside the Spring Boot, which is also meant for microservice development, they started to develop the Spring Cloud stack, which basically takes from the Netflix OSS stack tools that they have chosen, and they are wrapping up them in Spring-like environments, so you can easily use it. For example, if you want to start on a configuration server, all you have to do is to create a very, very simple and basic Spring Boot application and add configuration in it. So just say, okay, enable configuration server. So going further, you will have to know somehow how to discover your services. It's not like, for example, you are consuming an API and it's just one API and you know that it's always in that location and it's always there, maybe behind the balancer or something, but it's still there, that IP, that port and everything. Well, when you have thousands, maybe tens of thousands of instances of hundreds of microservices, then this can be a problem. And in this case, you will have to use a tool that will allow your microservices to register themselves once the instances are out, and also discover other services when they are needing to use them. And for this one, Netflix also have an example of tools, it's Eureka, and it's also part of the Spring Cloud stack offer. Going further, we also had load balancing when we were using the old monolithic applications. But the problem now is that once we are going to cloud, we have actually two types of microservices. There are the so-called middle tier microservices, are the, let's say, the normal ones that are used either based on other ones, so they call other microservices behind to gather data and compose them if replies forward, or they are edge services, and in this case actually they are interacting with the outside world. So those edge services are going to be managed a little bit more specially than the other ones. For example, when you are hitting an edge service, you might be interested in most of the cases of having some kind of security. When you're going to a middle tier, maybe you're not going to be interested that much anymore about security. And you also can use the edge services for API management. And in this case, for load balancing, the ribbon is the solution for client-side load balancing, which is actually used on the middle tier. And for the middle tier services, and for the edge services, you pretty much can use anything, but still, even if it's not mentioned here, there is also a solution from Netflix, which is called Zul. And basically, it's offering proxy and routing capabilities, and at the same time allowing you to define your own, let's say, filters, they call them, but pretty much you can do whatever business logic you want there. Going further, when you have, like I said, a lot of microservices and even more instances of each of them, it's very, very likely to have outages in production. And it's very likely that one of the microservices to try to make a call to another microservice which is well down, not available at the moment. And in this case, you need to have some kind of resiliency or secret breaker that will enable your application to somehow degrade gracefully or maybe even retry if your business allows it. In some cases it will be, let's say, feasible to retry. In other cases, if you want or you are forced to give a very, very quick answer to the end user, then you will probably just let it fail and make sure that it will reflect gracefully so it will not propagate the exception up to the edge service. And here you can use histories, which also can be used as monitoring for the state of your instances or microservices. And further, a lot of microservices and other microservice instances will of course produce a lot of logging and a lot of metrics, and all that has to be somehow merged. You have to gather that data and aggregate it in such a way that you will actually be able, when something goes wrong, you can easily see it, you can easily spot where it emerged, and you can go directly in that point and fix the problem. And for this one, we are proposing to use the ELK stack, which is actually Elasticsearch, Log-Stash, and Kibana. It's pretty standard actually. Also, AWS is using it and is offering that service with the SaaS platform. And basically, you can either go with your own installed and configured ELK stack, or you can go with the one from Amazon that they are offering. Either way, I would say it's very good. I would say it's a very good choice. And we were talking about having lots of microservices, with lots of instances, but we didn't say anything about how those instances are actually created, or how and when they are going to be scaled down or killed. Well, for this one, you will most probably want to do it automatically. But even in this case, there are two types. You can do it automatically. For example, like AWS is offering support via the auto-scaling groups. So, for example, you have a threshold. When that threshold of either memory, computing, or whatever resource that certain box is reached, it will automatically scale and start other instances to fill the gap. But it might be the case that you don't want to do that in that precise moment. And maybe you want to make sure that you will not be hit by a spike, a very big spike, like, I don't know, maybe some of the companies have, for example, the payment gateway will most certainly have spikes in holidays, let's say. Winter holidays, there are certainly a lot of spikes there, everybody's spending money, they are buying a lot of stuff, so there will be a large increase in the need of processing for that particular application. And if you don't want to be hit by a spike that can eventually put an application, then you want to do it preemptively. And for that one, for example, you will have to study your logs, your behavior of the application and behavior of your users, and based on that information, using a tool similar, or even this one, like Scribe from the Netflix, you can do it proactively. So Scribe, what does basically, it needs like, they are saying about 2 weeks ago, at least 2 weeks of data, So they can quite a bit say when you are need to scale, but do it before actually hitting the thresholds. So, as I was saying at the beginning, basically what we discussed so far was using Spring, because I mentioned Spring Boot, Spring Cloud that actually is based on the Netflix OSS stack. We talk about gathering logs and metrics using log/Elasticsearch and Kibana. We didn't mention about provisioning, but you can see there in the right corner is Docker, which is quite, I would say, quite on board now, and everybody starts and tends to use it. Starting us with also Amazon included it in their standard Amazon Linux instances. And for example, from a very, very high perspective, this would be how your microservice would look like. So, as you were mentioning, we have edge services that are behind the Azure proxy, which actually does the API management. And from that point, everything goes to Histix. Histix is actually going to manage any connection that you will have with a middle tier service. So in case, for example, you can say at Histix when he's making a call, say, okay, Histix comment in case of failure, just do a retry. Or in case of failure, just call a fallback method or something. For example, you don't get any context from the contact service, okay, just pretend that there are no contacts there. I return an empty list. That's a very simple example. You can see on both of them there is a Eureka client, which actually talks with the Eureka servers, which are actually offering the information about where the services are located. And even if in case that the Eureka server somehow goes down, so the entire cluster of Eureka servers is down, and nobody else is actually available to tell you where a service is, you still have on the client side the ribbon client. The ribbon client, each time when it connects to Eureka, it will cache the information on that server. And in case that Eureka is going down completely, it will continue to use that information up to the point when you, of course, start up again the Eureka servers. And all the configuration, as you can see there, examples in the top with the configuration properties, is made to the archives. Pretty much in the bottom line, we have the logs and Kibana, the old stack that's going to gather the logs and metrics. And I don't know. I would say that from this point on, we can start with questions.
Are you using the HTTP or DNS service discovery? So I don't know if the Netflix version is capable of handling both. I know for sure that other service discovery tools provide also fallback DNS querying and also HTTP querying. Both. And which version do you recommend to be used?
I would say that it depends. And also, if you look on the chemical blogs, they are telling you that, okay, they are using Eureka, they recommend to use it. They are going to use it also in combination with DNS and other stuff. And they also mentioned there that Eureka can